Okay, here's our lesson on completing the square. So when we're looking at quadratic relations, we have three forms. So we have standard form, factored form, and vertex form. We've looked at all three of these already. So let's review. Standard form looks like y equals ax squared plus bx plus c. And standard form gives us a key piece of information, and that is that the y-intercept is our c value. So standard form tells us about our y-intercept. In terms of a word problem, that would be our initial value, or where the graph hits the y-axis. The second form that we looked at was actually vertex form down at the bottom here, and it is y equals a x minus h squared plus k. The key piece of information that vertex form gives you, obviously from the name, is the vertex. So our vertex is hk. And don't forget, when you take that h out, you have to switch that sign when you take it out of the bracket. So hk is the vertex. And the third form that we looked at last chapter was factored form. Factored form looks like y equals a, x minus s, x minus r, or the other way around. And the key pieces of information that this gives you are the two x-intercepts. X-intercepts are r and s. So in terms of a word problem, this would be where it hits the x-axis, or when the ball hits the ground. Vertex form gives you the maximum or minimum, and then standard form gives you the initial value. So we were actually looking at how we're going back and forth between the three forms, sorry. The first thing we looked at was going from factored form to standard form, and we did something called expanding or foiling. So you'll probably remember it more by the word foil. So first, outside, inside, last. That's how we went from factored form to standard form. To go from vertex form to standard is the exact same thing. You would just expand and foil it. Last chapter, we looked at going the other way. So first, we looked at going from standard to factored. And obviously, we did that by factoring. And don't forget, there was 5 main types of factoring that we looked at. So if you have your little blue sheet still, the first way was looking for common factors, and then we were looking for difference of squares, perfect squares, the man method, so if it was a simple trinomial, and the last one was decomposition. That was the hardest one to do. To go from standard to vertex, we do something called complete the square. And that's going to be done in this chapter, complete the square. So once we learn complete the square, we'll be able to go from all forms. We know how to FOIL to go to standard, and we're going to know how to factor to go to factored, and complete the square to go to vertex. So why do we go from one form to the other? Well, if we're given a word problem, it's just easier to have a certain form depending on the question that they're asking. If they're asking for the maximum height or the minimum profit, if they have that word max or min, that's your vertex. So if they give you standard form, we're going to want to convert it to vertex form to get the vertex. If they're asking you for the x-intercepts, when does the rocket hit the ground? When does the ball hit the ground? We would want factored form. So we need to learn how to go back and forth between the three forms. Okay, so here's our note. If you have this printed out, that's great. You can fill it in. If not, please use lined paper and copy out write your own note for this complete the square. So 3 forms of a quadratic relation. First one, standard. Standard. Standard is y equals ax squared plus bx plus c. Second form is factored. Factored form looks like y equals a x minus r x minus s. And the last one is vertex. Vertex form looks like y equals a x minus h squared plus k. So there's our 3 forms. Recall perfect square trinomials and how they are easily factored. So in order to complete the square, we're going to have to create some perfect square trinomials. So let's just review how you factor these things. So if we have x squared plus 14x plus 49, you're going to want to know that the way to see a perfect square trinomial is if you can see that you can take the square root of the first term and the square root of the last term. I know I can take the square root of x squared, it's just x, and I know I can take the square root of 49, that would be 7. So if you can see that you can take the square root of the first and the last term, then you double check to make sure it's a perfect square. So how did we double check? Well, we took the square root of the first term, we multiplied it by the square root of the last term, and we doubled it. So we times it by 2. If that equals the middle term, so if that equals 14x, then I know this is a perfect square. So let's just double check here. 2 times x squared, the square root of x squared is 2x times 7, which is 14x, which is b. So this is a perfect square. So you don't have to write that out. You can just do that check in your head. Take the square root of the outside terms and double it. Make sure you get the middle term. So since we have doubled it and it does equal the middle term, this factors to square root of the first term, which is x, the first sign that you see, which is plus, and the square root of the last term, which is 7, and then we put a little squared on there. So it's x plus 7 squared. If we wrote it at x plus 7 times x plus 7 and FOILed that, we would get back to x squared plus 14x plus 49. So that is how we factor a perfect square. The next one, if you take the square root of the first term and the square root of the last term and double it, do we get 30? Let's just check. If we take the square root of 9x squared, we're going to get 3x. The square root of 25 is 5, and we're going to double it. So that's 15x times 2 is 30x, which is the middle term. So this is a perfect square. So how do we factor it? Well, we put our bracket here. I know it's going to be squared. You take this square root of the first term, so square root of 9x squared is 3x. You take the first sign that you see, so we got a plus, and the square root of 25 is 5. So 9x squared plus 30x plus 25 factored is 3x plus 5 squared. Now we got x squared minus 18x plus 81. Check to see if it's a perfect square. I can see that the square root of x squared is going to be x. The square root of 81 is going to be 9, and double it. So times that by 2. So we get 9x times 2 is 18x, which is the middle term. So this is a perfect square. So let's go ahead and factor this. We're going to have our bracket squared. Square root of the first term is x. The first sign that we see is a minus or subtraction, and square root of the last term is 9. So this factors to x minus 9 squared. And the last one, square root of the first term is x. Square root of the last term is 12. Double that. So 12x times 2 is 24x, which is the middle term. So this is a perfect square. When we factor it, we got a bracket here, squared. The first term is x. The first sign that I see is a subtraction. And the square root of the last term is 12. So x minus 12 squared. All right, find the missing value for each perfect square. If we want to create some perfect squares, we need to figure out what would be missing. So if I have x squared plus 18x plus blank, and I want to make sure that's a perfect square, I know if I take the square root of the first term, which was x, and the square root of whatever's under in this blank, and double it, I'm going to get 18. So let's just work backwards. Instead of doubling it, let's take 18 and divide it by 2. And then we're going to have to square that. So 18 divided by 2 is 9. 9 squared would be 81. So when you write your answer here, you don't actually need the square root. That's just going to equal 81. Double check. If I take the square root of the first term, square root of the last term, and double it, we're going to get 2 times 9x is 18x. So it works. Okay, let's do the next one. Oh, next one's over here, number 2. X squared minus 2x plus blank. I want to make sure that's a perfect square. So what you're going to do is you're going to take your middle term, you're going to divide it by 2 and square it. So negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. You can double check that in your head. If you take the square root of the first term, which is x, square root of the last term, which is 1, that's 1x, and double it, you get 2x. Number 3, x squared plus 6x plus blank. So I'm going to take that middle term, which is 6 divided by 2, and square it. So 6 divided by 2 is 3. 3 squared is 9. Double check. Square root of the first term is x. Square root of the last term would be 3. So that's 3x, and we double that, we get 6x. Over here now we're missing the b value. Well, I know that b equals twice the square root of the outside terms. So square root of x squared is x. Square root of 64 is 8. So 2 times 8x is 16x. And this one we're missing our b value, so I know that b is twice the square root of the outside terms. So we have square root of x squared is x, square root of 100 is 10, so that's 10x. Let's double that, we get 20x. And the last one, I know b is twice the square root of the outside terms. So square root of x squared is x, square root of 1 is 1, double 1x, you get 2x. Completing the square is a method or technique used to convert a quadratic in standard form to vertex form. To create a perfect square given an equation of the form y equals ax squared plus bx plus c, we look at the first two terms and add a new term, b divided by 2 squared. I'm going to go back over that once we do an example here, because that's really just going through the steps. So complete the square to convert to vertex form, and then state the vertex of each parabola. If I have an equation y equals x squared plus 8x plus 15, I can tell this is not a perfect square because I cannot take the square root of 15. So right away you can see this is not a perfect square. Why do I need a perfect square? Because I need something that looks like this in order to get to vertex form. I need this squared part to get to vertex form. So that's why we're looking for a perfect square. So since we don't have a perfect square here, we're going to have to create one. So here we go. To create my perfect square, I want to keep my first two terms. So I'm going to write down y equals x squared plus 8x. So I'm keeping my first two terms the same. The problem is I can't use this 15 as my c value because that is not a perfect square. I need a different c value. How do we find that c value? Well, we do exactly what we did on the other page. We are going to create a perfect square. Here we go. To find our magic number, the magic c value here, I am going to take the b value. Let me just clean this up for you. I'm going to take the b value, halve it, so divide it by 2, and square it, just like we did on the other side. So my b value is 8. I'm going to divide it by 2, and I'm going to square it. So let's do 8 divided by 2 is 4. 4 squared is 16. So I know if my c value is 16, I'm going to have a perfect square. So what I'm going to do here is I'm going to add 16. The problem is I can't just add 16 to an equation. That changes it. So if I add 16, I also have to subtract 16. I'm just going to erase this and move it over. Okay. Now, I still need this 15 here, so I'm going to write down the plus 15 on the end. So because I added the 16 and then subtracted the 16, I actually didn't change the equation at all. It's still the same equation because really you're just adding 0. But what we were able to do is create a perfect square with our first three terms. So now if I factor this perfect square, don't forget perfect square looks like this. You're going to take the square root of the first term, which is x, the first sign that you see, which is plus, the square root of the last term, which is 4. So that takes care of my first three terms. I still have this minus 16 plus 15 on the end. So it did not get rid of this stuff. So now I'm going to go one step further. I get x plus 4 squared, and negative 16 plus 15 is actually negative 1. So now this looks like vertex form. We can pick out what our vertex is going to be. So because our vertex is HK, and we're always going to switch the sign, get rid of that. We're always going to switch the sign. Our vertex is going to be then negative 4, negative 1. So that is completing the square. Let's try it again. We got y equals x squared minus 12x plus 40. So in order to make a perfect square, I'm going to keep those first two terms, x squared minus 12x, but I need to create that perfect square, so I need that third term here. In order to find that value, you're going to take the b value, which is negative 12. We're going to divide that by 2, and we're going to square it. So this is our magic number. Negative 12 divided by 2 is negative 6. Negative 6 squared is 36. Anytime you square a negative, it's going to be a positive. So our c value should always end up being positive. So since I have a magic number of 36, I'm going to add 36. And because I added 36, I also have to subtract 36 and plus 40. That 40 does not disappear, it goes on the end. So what I've done is I've created a perfect square with my first three terms. So when we factor this, we're going to get our two brackets here and square it. I'm going to have the square root of the first term, which is x, the first sign that you see, so subtraction, and the square root of the third term is 6. So x squared minus 12x plus 36 factors to x minus 6 squared. Do not forget, we still have a minus 36 and a plus 40 on the end. So our final answer then is going to be x minus 6 squared. Negative 36 plus 40 is actually plus 4. So our vertex is going to be HK, which in this case is positive 6. Always switch that sign when you take your H out. The K value is 4. So your vertex is 6, 4. Number 3. X squared plus 2x plus 4. Is this a perfect square? If you take the square root of the first term and the square root of the last term and double it, does it give us the middle term? Let's see. If we take the square root of the first term, it's x. Square root of the last term would be 2. And double it, it's going to give us 4x. So even though it looked like a perfect square, it is not a perfect square because the middle term is 2x, not 4x. Okay, so we're going to have to complete the square here. I'm going to write down the first two terms, x squared plus 2x. I need to figure out what that third term is going to be so that I have a perfect square. So I'm going to find the magic number. Magic number, you always take the b value, divide it by 2, and square it. 2 divided by 2 is 1. 1 squared is 1. So I'm going to have to add 1 to create my perfect square, but because I added 1, I got to subtract 1 as well. And then don't forget your last term, plus 4. If you make any errors here, it's going to be that you're going to forget this 4 last term here. Okay, so let's do some factoring. First three terms is the perfect square. If I factor x squared plus 2x plus 1, what do we got here? Our two brackets squared. Square root of the first term is x. First sign that you see is plus. Square root of the third term is 1. So x plus 1 squared. And then don't forget, we still have those two last terms here, negative 1 plus 4. So negative 1 plus 4. And let's simplify this. We got x plus 1 squared. Negative 1 plus 4 is plus 3. So our vertex is HK. We're going to switch that sign for the H, so it's negative 1, positive 3. So if this was a word problem and they tell you that the equation is y equals x squared plus 2x plus 4, and they're asking you a question about the maximum or minimum value, you'd want to change it to vertex form by completing the square, and that way the vertex just jumps right out at you. There's your answer. Okay, last one. X squared minus 4x plus 5. I can tell it's not a perfect square because I can't take the square root of 5. So I'm going to write down the first two terms, x squared minus 4x. I'm going to find my magic number here. I need my magic number to create my perfect square. So I'm going to take the b value, divide it by 2, and square it. Negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. Remember, that always has to be a positive. So to create my perfect square, I'm going to add 4 here. But because I added 4, I have to subtract 4 too. And then my last term is plus 5. Don't forget about that plus 5. So my first three terms is a perfect square. When I factor this, I'm going to have my bracket squared. Square root of the first term, which is x. The first sign that you see, which is subtract. And the square root of the third term is 2. So x minus 2 squared. Now don't forget, we still have minus 4 plus 5 on the end. And for our last step, we're just going to simplify this. X minus 2 squared. Negative 4 plus 5 is plus 1. So therefore, our vertex is 2, 1. So we switch the sign of the H when we pull it out there, HK. Okay, I want you to do the practice on page 270. Do all of these questions. All of these questions are similar to the ones we just did. The more completing the square examples that you do, the better. So the more you practice this stuff, the more you're going to remember it. Make sure you're doing this homework, and then we'll meet at 12:30 to discuss if you have any problems. We'll meet again tomorrow as well. Okay, there is a second part of this lesson. So if you want, take a break, do this practice, make sure you're checking the back of the book to see if you got the right answers, and then come back to this video to watch the second part of the lesson. So the second part of the lesson is the same type of stuff, it's just adding one more step. So pause if you want, stop the video, and then come back to it when you're finished that practice on page 270. If you're having any issues at all, please don't hesitate to email me. I will walk you through answers. I will help you. Don't hesitate to email. Okay, the second part of the lesson. This is usually done the next day. However, we are steamrolling through this stuff. So what happens when it doesn't start with x squared? So like this example, there's something out in front. There's an a value. We cannot just use our magic number if there's something in front of the x squared. So make sure you're really looking at these questions. If there's nothing in front of the x squared, you can do exactly what we did on this note here. You can just find the c value by taking the middle term and dividing it by 2 and squaring it. However, if there's something out in front, we need to do an extra step. So here we go. Y equals 2x squared plus 12x minus 3. Your first step is to common factor the 2 out of the first two terms. You don't have to common factor it out of the third. You can tell already the third term is negative 3. We can't even divide that by 2. We would get some decimal number or a fraction, and we don't want that. So only take the 2 out of the first two terms. So I'm going to take a 2 out. I'm going to divide both of these by 2. 2x squared divided by 2 is x squared. 12x divided by 2 is plus 6x. Okay, so I took a 2 out of the first two terms, common factored a 2 out. I still have the negative 3 on the end. So the negative 3 goes outside the bracket. Now, we're going to create a perfect square. So we have 2 bracket x squared plus 6x. I want this to be a perfect square here. So I'm going to find our magic number. When you find your magic number, you are using the 6x as your b, not the 12 from the original question. So you're using the new b value that you created here. So our C, our magic number, is going to be 6 divided by 2 squared. 6 divided by 2 is 3. 3 squared is 9. So our magic number is 9, which means in here I'm adding 9 and I'm subtracting 9. That is all done inside the bracket. I still have minus 3 on the end. Okay, so I added 9 and subtracted 9 inside the bracket. Still have the minus 3 on the end. What I've done here is I've created a perfect square, my first 3 terms. Our next step, keep that 2 out in front. Write our bracket out, squared. So we got square root of the first term is x. First sign that we see is a plus. Square root of the third term is 3. All right, so what are we going to do about that negative 9 here? Well, we're going to throw some brackets around here. And we're going to write our negative 9. And then end our bracket. Okay, so our negative 9 still is with that 2. That's why we need the brackets around it. And our negative 3 is off by itself on the end. So our next step, we need to get rid of these square brackets. How do we get rid of the square bracket? Well, we have to distribute the 2 to the first bracket, which is x plus 3 squared. And we have to multiply the negative 9 by 2 as well. So in order to get rid of those square brackets, we need to multiply both terms by 2. The first one, just put the 2 out in front. 2x plus 3 squared. So that's distributing the 2 to the x plus 3 squared. The next step is distributing the 2 to the negative 9. So 2 times negative 9 is negative 18. So now our square brackets are gone. Don't forget to minus 3. And our very last step, we're just going to simplify this. X plus 3 squared. Negative 18 subtract 3. If you're in the negatives 18 and you're going in the negatives 3 more, you're actually at negative 21. So our answer is 2x plus 3 squared minus 21. So this is a little confusing, I know. Let's just do another one here. We got 2x squared minus 20x plus 43. First step, you're going to common factor the 2 out of the first 2 terms. So take this 2, put it out front, divide each of the first 2 terms by 2. So 2x squared divided by 2 is x squared. Negative 20x divided by 2 is negative 10x. And we still have the plus 43 on the end. Our next step, we're going to create a perfect square. So x squared minus 10x. I need to figure out what that third term is going to be to make this a perfect square. So we're going to find our magic number. C equals, we're going to use our b value here, which is negative 10. So negative 10, divide that by 2 and square it. Negative 10 divided by 2 is negative 5. Negative 5 squared is 25. So to create my perfect square, I'm going to have to add 25. And then I'm going to have to subtract 25. That is all done inside that bracket. And don't forget about 43. 43 is still there. My first 3 terms have become a perfect square. So when I write this out, I'm going to have 2. Square root of the first term is x. First sign that I see is a minus, so subtract. Square root of the third term is 5. I still have this minus 25, but that's all in brackets. So I'm going to need those square brackets around this. And my last term is plus 43. Your next step is to distribute this 2 to the x minus 5 squared and the minus 25. So 2 times x minus 5 squared, well, we're just going to put 2 times x minus 5 squared. However, 2 times negative 25 is negative 50. So you can't just pull the negative 25 out. You have to multiply it by the 2 because it's in the brackets with the 2 out front. And don't forget plus 43. So our very last step, we're going to simplify 2x minus 5 squared. Negative 50 plus 43 is negative 7. Let's do another one. We got a negative out front this time. So when we take that negative 3 out, we're going to make sure we divide both terms by negative 3. So negative 3x squared divided by negative 3 is x squared. Negative 18x divided by negative 3. Watch your signs here. You have a negative divided by a negative is actually a positive 6x and plus 2. Next step, we're going to create that perfect square so we can factor it. So we got x squared plus 6x. My c value is going to be that 6 divided by 2, and we're going to square that. So 6 divided by 2 is 3. 3 squared is 9. So I'm going to add 9, and I'm going to subtract 9. And don't forget your 2. Next step, we're going to factor this perfect square here. First 3 terms is a perfect square. So we got square root of the first term, first sign that I see, square root of the third term. I still have the negative 9, and that is in brackets, so don't forget to put that in your bracket. And plus 2. To get rid of those square brackets, we're going to have to distribute the 3 to both terms inside. So when we distribute the negative 3 to the first one, we get negative 3x plus 3 squared. When we distribute the negative 3 to the negative 9, well, negative 3 times negative 9 is positive 27. And then we have plus 2. So our last step, we have negative 3 x plus 3 squared, and 27 plus 2 gives us 29. Our next one only has 2 terms, so this one looks a tiny bit different than what we're used to. The only thing out front is a negative, so all we have to do is common factor a negative out. So if I divide negative x squared by negative 1, I'm going to get positive x squared. And if you divide 4x by negative 1, we get minus 4x. And we don't have a third term, so that's all we're going to do for that one. Now we're going to create our perfect square. So x squared minus 4x. To create my perfect square, I'm going to use that b value, which is negative 4. I'm going to divide it by 2 and square it. So negative 4 divided by 2 is negative 2. When I square that, I get positive 4. So I'm going to add 4. And don't forget to subtract 4. All right, I've created a perfect square, my first 3 terms. So when I factor this, I have a negative out front, square root of the first term, first sign that I see, square root of the third term, and I have that subtract 4, and don't forget that is all in a square bracket. When I distribute that negative to both terms inside, I'm going to get a negative x minus 2 squared, and negative 1 times negative 4 is plus 4. And last example here, we're going to do one with a decimal. So don't let the decimals scare you here. We're going to do the same type of thing. We have a 0.5 out front, so I want to make sure I common factor that out. So 0.5. When I take 0.5x squared divided by 0.5, you're just left with x squared. When you have negative 2 divided by 0.5, you're actually going to get negative 4x. So when you divide by a decimal, the number actually gets bigger. And we have a plus 5 on the end. I'm going to create a perfect square. So we got 0.5 out front, x squared minus 4x. I need that third term. How do we find it? Well, the magic number is going to be our b value divided by 2 squared. Negative 4 divided by 2 is negative 2. We're going to square that to get positive 4. So to create my perfect square, I'm going to have to add 4, but because you added 4, you got to subtract it too. And don't forget your plus 5 on the end. I've created my perfect square, so let's go ahead and factor that. Don't forget to keep your 0.5 out front. Square root of the first term is x. First sign that I see is a negative. Square root of the third term is 2, so that's x minus 2 squared. And then I still have my subtract 4 here, but all of this is multiplied by 0.5. So put your square brackets. We have a plus 5 on the end. We're going to distribute that 0.5 to both terms inside. So we have 0.5 times x minus 2 squared. And now we also have to take 0.5 and multiply it by -4. So that's going to give us -2. So half of 4 is 2. And then we still have a plus 5. Our last step, we're just going to simplify those last two terms. So we have -2 plus 5 gives us plus 3. Okay, more practice. Same page, same type of stuff. We're still completing the square. We just have an a value. So these questions that I have laid out for you next all have an a value out front. Make sure you practice that. Make sure you check your answers in the back. Make sure you email me if you have any questions, and we'll take up any questions from the homework in our next Teams meeting.